weeks, we shall have we'll have 3 more talks. We will share the details of each talk as it becomes ready. So for now, I will share my screen, then we can start. Now, maybe one more thing I'll mention is that behind the scenes, there's a lot of mathematics that happens, but we shall try to avoid too much mathematics in the presentations and focus on the conceptual level for easy understanding. And then we'll have a short presentation, hopefully not more than 20 minutes. Then after that, we will do a live demonstration using Python to demonstrate the same concepts. So it would be nice if you knew Python before this, but I'll try to explain to the best of my ability, and then we shall share the script that contains the code as well, so that those who wish to try it on their own will be able to do that. So I'll just share my screen now. And may need some confirmation that the slides are visible.
Yes, they're visible on my end.
Okay. Let me make it full screen and are they still visible? You can see?
Yes, they are.
Good. Fine. So probably the first stop for us will be to go to the introduction. So why do we need to understand customers in a business context? So essentially, this will help you to target them better. The concepts we learn gives you that foundation to enable you to target them better, give them a better experience, and then you drive strategic decision making with some clarity, not just with some generic techniques, but with clarity, and this puts you ahead of your competition. So the ideas here help you to minimize the guesswork and improve your return on investment and also your conversion rates, as well as give you advantage in the market, and you're able to adjust better to new developments in the market because you have the data and the information. So as an overview, we already looked at the importance of segmentation. So we shall see how machine learning will revolutionize this segmentation. And at the end of it all, we shall look at the practical demonstration and what other steps you can take to learn more. So here we have the challenge. The task at hand is customer segmentation, and the traditional techniques usually use generic methods to segment customers, but these techniques are not very reliable. They're quite subjective. They are hard to scale and can be very inconsistent. So machine learning puts everything in focus and can handle very large data sets efficiently, and are able to dig deeper and find the intricate patterns that human beings may not be able to pick up on their own. And also, anytime you have new information, the machine learning techniques can take up the new information and digest it, which may not be possible if someone was doing it with the traditional techniques. So the data we'll be looking at looks something like this. We have data on customers. We have the invoice number. The variables that will be of interest will be the invoice number. We'll also be interested in the quantity, the invoice date, the unit price. The unit price and quantity will help us compute the total sales. And we'll also need the customer ID to be able to identify the customers. So this is the data that we shall be using. Ultimately, we will not use it in this form. We'll have to do some transformation on it to be able to apply the customer segmentation. We shall see how that will be done. So this explained what machine learning-based segmentation does. So we have some algorithms that work to find clusters. The clusters are found based on similarities between the customers, and the similarity is based on some kind of distance measure. In our case, we shall be using the usual distance measure, the Euclidean measure, which is what you learn in high school, how to measure distance between points. We will use that to measure the distance between points in our data set. And then we should be able to pick up some patterns that would otherwise not be able to see through some manual analysis. So the advantage of this is that it's something you can do all the time. It does not depend on the person doing it. It's actually objective and can be repeatable. And you can dig deeper and get more precise information that can inform your resource allocation and hopefully get better return on investment and better conversion rates for your marketing. Now we shall focus on one technique. There are many techniques you can use for customer segmentation, but we shall focus on essentially two, because we shall do the RFM analysis and use the data from the RFM analysis to feed it into the K-means algorithm to find our clusters. So essentially that is what we shall do. There are many other ways you can do this, but I think we don't have too much time to do all of them. So the main ideas would be recency. That's just how recently the customer made the purchase. Frequency simply means how often the customer made purchases. So you can count how many times the customer made a purchase during that period. There's the monetary value. In the period of consideration, this simply means the total amount of money spent by the client during that period. So using these RFM values, you can construct a score and use this score to segment the customers, but we shall not focus on the score. We shall just focus on the RFM values and feed that into the K-means algorithm to find our scores, our clusters, and use them to segment the market. So after we process the data, the initial data that we saw will be processed so that we can compute these values for the recency, frequency, and monetary. So recency will simply check the number of days since the last purchase. Frequency is the number of purchases the client makes, and monetary is simply the total amount of money spent during the period under consideration by the client. So this will be done for each customer. So each line represents a single customer. All that will be done in Python. For now, I'm just showing what the output will look like. So K-means clustering is the next thing we need to consider. Now, K-means clustering is an unsupervised learning approach to machine learning. It does not require labeled data, and that means from the onset, you don't know what clusters are in the data. So you're sort of exploring to find what clusters may be in the data. Again, this I mentioned already. The K-means will group the customers based on similarity. That similarity is on some distance measure. In our case, it's going to be the Euclidean distance. There are other measures as well that may work for this, but what we shall use is the Euclidean distance in our case. Now, the K-means works best if the variables have a normal distribution, and that means they should be symmetric, and they have means and variances that are the same. So this may not be the case with the initial data set, so you have to do some processing to achieve these conditions to make your predictions better. So, but luckily there are ways you can do that in Python. We shall see how that is done once we get to the demonstration. So the example we shall use is what I've already shown. It's e-commerce shoppers. We shall use the frequency, recency, and monetary value to do the clustering. And this will be able to help us differentiate the different types of clients we have. Are they just casual browsers, those who only show up during sales? or are they power buyers who are frequently purchasing on your site? And based on this, you can determine different ways to target them. So this is a basic example that we'll be using. Now, the other thing about k-means is that you need to predetermine the number of clusters beforehand. Before you run the algorithm, you must know how many clusters you're looking for. So there are two ways you can do this. You can use your business context to guide the number of clusters, but then you have the mathematical way of doing this using the elbow method. So this graph is generated by Python, and then it's computed these values of the within cluster sum of squares, which sort of measures the quality of your clustering. The larger the value, the worse your clustering is. So as you go down, the most likely number of clusters that would work for you would be where you find the elbow. That's why it's called the elbow method. So you can see there's an elbow here. There's also a slight elbow at the third cluster. So a good experiment would be to try 2 or 3 clusters. In our example, we shall use 3 clusters. And then this must also make business sense. So you have to include someone with some domain knowledge in the area you're working in, so that everything works out best. The elbow method simply gives you an advisory, but it's not cast in stone, although it gives you a good idea of where to start so that you don't guess. So you can combine this with the business experience to come up with the appropriate number of clusters. So once you figure out this number of clusters, then you have to apply the k-means. So this is how it works. We shall try to use a case where you have only 2 variables, and then you do a scatter plot of the 2 variables. So initially, you don't know where the clusters are. These will all be probably of the same color, and you don't know which cluster they belong. So the first step that k-means does is to pick random clusters, they may be of any size, and pick centroids from those clusters. So this is the initial step. These centroids are just random with random clusters. They may not be meaningful at this point. So after they pick the centroids, now you measure the distance of each point to the centroids and assign each point to the centroid which is closest to it to form a cluster. So that happens. And then once you form the new clusters, you use those new clusters to create, calculate the new centroids. So you can see at the second step, we have new centroids. So these are the clusters that were picked up from the first step, and these are the new centroids determined by the new clusters. So the process is now repeated on this, and then you will have, at each point, you keep getting new clusters and recalculate the centroids. And this goes on until the clusters are no longer changing. So you can see from the 4th iteration here to the 5th, there doesn't seem to be much change in the clusters, right? So we told you to look for 3 clusters. These are the 3 clusters it has found in the data. So these become your different segments in your market, and then you can isolate them by looking at some descriptive statistics or other graphical techniques to see what characteristics these different clusters have and what targeting methods you can use for those clients. So in a nutshell, this is what it does. There's a lot of mathematics behind it. I think if there's interest in that, we can organize for a talk where we cover the deeper concepts. But this is essentially what happens with k-means. Now, this shows only when you have 2 variables, but the same idea can be extended to several variables. It's the same idea, but it's not possible to visualize it. But the idea is the same. It doesn't change so much. It's just extended to several variables. And most of the time, you'll be dealing with more than 2 variables. So this is a bit oversimplified, but it brings out the concept all the same. So once you find the clusters, you can now attach the clusters to your data. So this was our data which you had transformed to compute the recency, frequency, and the monetary value of the customer. And once k-means will cluster all of them, and we'll be able to assign each client to a cluster. and add that to our data. So for instance, now we were looking for 3 clusters. Each we label the first cluster 0, the second one 1, and the third cluster 2, and each customer has been assigned to 1 cluster. So this is part of the data with the cluster assignments already done. So with this now you can group by the clusters and get basic statistics from the 3 variables: recency, frequency, and monetary value, and be able to use that to cluster your data. You can visualize the clustering. In our case, we have a dimensionality reduction technique called the principal components analysis. So this one, we will not go into the details of this, but it just enables you to visualize high dimensional data. In our case, we had 3 variables. So we could have done a 3-dimensional plot, but that is hard to, sometimes it's hard to visualize because there are so many angles from which you can look at them. But when you use PCA, you can use the first 2 principal components and you get the visualization. So we have colored the points using the clusters that were obtained from the k-means, and these are the 3 clusters that have been obtained. Then we can now dig deeper and try to figure out the characteristics of these clusters. So we use you can make a table with these values, but I think the graphs give a better view and easy understanding. So now for each of the variables, for recency, we have computed the mean for the first cluster, which was labeled 0, the second cluster, which is labeled 1, and the third cluster, which was labeled 2. So for each of the variables, we compute means for each cluster. So if you are to look at the first cluster is a bit moderate on recency. I think this can be said to be low on frequency and also low on monetary values. So with that, now you can go to your marketing guy and they can work out a strategy to target those ones. So these are probably customers who are at risk of churning, and you may need strategies to target them. So the second cluster you can see is low on recency. Low recency is a good thing because this means they bought more recently. They are high on frequency and also high on monetary value. So these are your high value customers. You can give them some VIP cards and find some appropriate targeting technique. So you can also make the same considerations for the third cluster. The third cluster you see is high on recency. That is bad. If high on recency means the last time they purchased is a long time ago. They also didn't buy that often, so the frequency was low, and the monetary value also they didn't spend that much. So again, based on that, you can work on a marketing strategy that targets those groups. So these are some of the applications. The one we are looking at is the e-commerce data. I think it's just repeating most of what we have said. You tailor the offers for each segment. For banking, you can determine risk profiles and so on for your customers and see how to cross-sell opportunities to them. So this now consolidates the business context that we want to look at in the demonstration. So we have an online retail business that wants to improve the customer relationship management by identifying the segments. So these are the things they aim to do after identifying the segments. Hopefully, they can achieve this. So the problem is they don't understand the customer base, and the marketing campaigns have been generic and giving poor returns on investment. Basically, they're not efficient and they miss a lot of opportunities that would help them grow their revenue. So they need to identify the segments, work with the segments to gain insights and developing targeted strategies for those segments. They can now then they can implement the retention initiatives to keep their customers around a little longer and also be able to optimize their resource allocation. So you focus more efforts on customers who are more likely to convert. And these are, again, we have mentioned these already, but they are the insights you can get from the segmentation. We shall see this in the demonstration. Some of these we shall see in the demonstration, how it is worked out. So there are other segmentation techniques which we shall not cover, but those ones who are interested can look them up. So it's a very rich area with a lot of work to do. So this is an invitation for anyone who is interested. They can try to look up some of this and further your knowledge on the segmentation techniques. So this is summary of what we have done. So maybe the whole presentation is now summarized in one slide. We did some RFM analysis. We have talked about k-means clustering, how to apply this to the RFM data. Then using that to segment your customers. Now, once you have that, you can integrate that into your customer relationship management system and be able to make better decisions. So this again just repeats what I've said earlier, how to apply this in your business. You can integrate it into your customer management system. So the tool we are going to work with today is Google Colab, which is, you can run it online, so you don't need to install it on your laptop. And then the language we shall be using is Python 3, which is an open source programming language, and it's very good for data science. I think industry people really love Python. Some in academia prefer R, which can still do this. But today we shall work with Python. There are also other places you can get more information. You have these community forums like Kaggle. There's a lot of data and sample code there that you can use. Stack Overflow has a lot of people to answer your questions. There's the scikit-learn is the library that we use for running some of the clustering algorithms, including k-means. So there's official documentation. You can read that. And the other online courses you can take from different platforms like Coursera, Udemy. I've done mostly DataCamp. That's what I've done. Coursera and Udemy also are useful. And these are some of the references you can use to read further. So the number 4 is the scikit-learn documentation. And number 5 is the source of this data. The data came from the University of California, I think it's usually Irvine, machine learning repository. You can access it and download it. So the data is not mine. I got it from, it's publicly available from this repository. You can access it and play around with it. So I think that brings us to the end of the first part. So we could take questions now, or we could just move on to the coding demonstration. If there are any questions that are burning, we can take a few now, then we proceed to the demonstration. Am I still audible?
Yeah, Prof, you are.
Okay. So I suppose there are no questions now. We can proceed to the coding demonstration. Now, Could you confirm if you can see my screen now? I've shared the.
Yes, it's visible.
You can see the code, right?
Yes.
So I don't know whether it's too small or I'll try to enlarge so that we can see this. So this is a platform we are going to use for coding. It's called Google Colab. You can access it if you have a Google account. I think this should be possible. So I will share the link to this code after the presentation, and you can download it and try it on your own. So if you have not used Python before, a lot of things here will look like Greek. But what I propose is that you focus on the concepts. The concepts are not too hard to follow. And once you get the code, you can try to run it. You don't have to do anything special. Now, I have my data in the Google Drive, so I'll just pick it up from there. But if you don't have your data in the Google Drive, it's possible to just upload it from your computer. Looks like there's some comments. Are there any comments? Oh, that's from Mtisia. Maybe you can record on.
Yes, the session is being recorded. So I think I'll
It says
upload
you
it.
have limit. Oh,
No,
are you
it's not.
recording it locally or?
I'm recording it locally.
Okay. Okay, so all said and done, this might make more sense for someone who already knows Python, but I'll also try to explain the concepts as we go along and what it does. So the first thing you do is there's a lot you can do with the basic Python, but it's usually not enough. So you have to import a lot of libraries to assist you achieve certain analysis. So these are the libraries that we need. Pandas deals with the data frames quite well. NumPy is good for dealing with the numbers. Matplotlib is for plotting, and Seaborn as well. Scikit-learn is good for machine learning. In particular, we shall be using it for clustering and preprocessing the data. And then datetime is for handling dates. So let me run that and see. So that one runs quite fast. So the next one is the data itself, which is in my Google Drive. So I will read it. It's an Excel file. So this reads the data. Takes a bit of time, maybe about 1.5 minutes. It's a big file. It's about, it has over 500,000 records. So takes a bit of time to read. So one way, if you, sometimes what you can do is sample a file like this so that you don't have to work with all the 500,000 records. And then using the sample, you can do some basic analysis. And sometimes when the records are too many, you lose, some patterns will not be visible, they'll be clouded. So it may make sense sometimes not to work with the whole data set, but to take a random sample and do some exploration with the sample, the smaller sample. But for our case, we shall use the whole data set. So in a few seconds, I think it will be done. It's still rolling, so still loading the data. I think it is done. So sometimes when you are accessing data in the Google Drive, you may need, there's this, I've commented out this first, there's a block that is up here. If it doesn't, if this line for loading the data doesn't work, you may need to mount the Google Drive. So this block that I've commented out, you'd have to uncomment it. That is, remove the hash symbols and then run it first before you can import your file from the Google Drive. So as it is, it will not work directly on your machine. You will have to indicate the source of your, the file that contains, the folder that contains your file so that it loads. Maybe at the end, we can come back and we see how to look at this or a different way to do this. So we can now look at the first few rows of the data here, showing the variables. So this is now, if you want to see it as a spreadsheet, this is what it looks like. Now, initially, the data does not have this column for total sales. I ran this after computing it much later. That's why it's appearing here. The total sales does not come with the data. So you'll have to use the unit price and the quantity to compute the total sales. But this is what the data looks like. Now we'll do some processing. We check if the data has missing values. And when we run this one, we get all these two variables, description and custom ID. Custom ID has 135,000 missing values. So this custom ID is really important for our analysis, and therefore we will have to drop all these customers who don't have an ID. So the next one also just inspects the dataset. This is .info method on the data frame. It gives you information about each variable, the type of variable, and the number of non-missing values. So you can see even for custom ID, it has fewer values because it has a lot of missing values. It has 406,000 as compared to the others. So the total records are 541,909, but custom ID only has 406 null values. And we shall remove the null values so that we are left with the complete data. So the next, here we drop this part drops the missing values. We left with only rows that have complete data without any missing values. So now if you inspect after removing the values, you can see each variable now has exactly the same number of records. This has 406,829 records, and all of them have the same number of records. So now every record is complete. Already we can see the variables seem to be of the correct data type. In particular, the invoice date is of date time type, which is what we want. But just in case it wasn't, you'd have to convert it to a date time because we need to run some operations that depend on that. So that Python can know that it's a date and correctly run the operations. You also need to ensure that quantities are not negative, just in case there's a negative quantities. This next line, we remove them. Because negative quantities are bad data for us. The next one simply computes the total sales using the quantity and the unit price. So you can see even before you start the analysis, there's a lot of work that you would have to do, but with a bit of experience and guidance, you'll be able to do this. Now that the data is basically in the way we want it to be, you can now compute the recency, frequency, and monetary values for each client. So I'll share this with you. There's some notes here that should help you understand what is going on. Once you get it, you'll be able to read them. So this next code here simply does that. It computes the recency, which is an amount of time since the last purchase, frequency, the number of times the client makes purchases, and the total sales, the total amount of money spent during the period under consideration. So this will now give us the RFM. Now this is calculated from the data set that we loaded. So now this is what we want. Now K-means usually likes to have numeric variables. So we have all our variables are numerical. It's possible to work with categorical variables, but you would have to transform them. We shall not consider that now for our case. We just focus on RFM only. But it's still possible to work with categorical variables. You would have to transform them into dummy variables, but we don't have any of those now. So now data is ready, almost ready for analysis, but it has a few problems. Now you can see they are all on different scales. The data is on different scale, but k-means works better when the data is on the same scale. They have the same mean and variance. It also works better if the data is not skewed. Right now, by looking at this, we can't tell if it's skewed or not. But if we run there's this descriptive statistics, we can run that on the RFM data. So by looking at the descriptive statistics, we'll be able to check the spread and different. You can see the means are quite different and on different scales. These are the means. They have different standard deviations. That's not so good for k-means. And so on. If you look at the monetary value, it has a zero value somewhere. The minimum value is zero. Now, this might cause us problems later on when we are doing some transformations, but what we can do is to add a small value to the zero or to all the values in monetary so that we have non-zero values throughout. There's a transformation that we do later on that requires all values to be positive. And we have a way around that. But this basically tells you they are not the data. Now, but from the numbers alone, sometimes it's difficult to figure that out. We can use the pair plots from Seaborn. So the pair plot gives us an idea of the distributions and scatter plots of the pairs of variables. So sometimes you are lucky, and even just from these pair plots, you can actually see the clusters. Not so much in this one. We are not lucky. The clusters are not easily visible in this case. So you probably must do further analysis to see the clusters. But we can also see the distributions of the variables. So all of them seem to be skewed to the right. But this is not, we prefer that they are normally distributed and have the same mean and variance. So that means we have to do some transformation. Use a Box-Cox transformation. There's a description for that here. When you get the file, you can just run through that. So this is supposed to make the data closer to the normal distribution. If possible, it may or may not happen, but at least it tries. And then the values are now more comparable. So that's what this code does. It simply applies the Box-Cox transformation on each of the variables, and we store everything in a new data frame called the RFM transformed. So I'll run that. I think it has worked. So we now plot the transformed data. Now you can see we haven't got quite what we wanted. For the first one, there's a bit of symmetry. It's not as skewed as it was. At least we have lost the skewness. What we have not gained is a perfect normal distribution. But there are some patterns that have come out. When you see multiple peaks, these multiple peaks indicate that you have some clusters in your data. You can see that in this first plot, the distribution of recency. So there are about 3 peaks, suggesting that maybe there are about 3 clusters. The same happens with the frequency. Frequency also has about 3 peaks in the distribution. Monetary seems to have 1 big peak and maybe these other smaller values. So also from these graphs, you should be able to pick out outliers, but we shall not remove outliers from this. So in the ideal world, this transformation should have given us some normally distributed data. But in this case, it hasn't. We can still go ahead and use k-means anyway, because sometimes it will still pick up the clusters. But the other techniques, for instance, if you there's a technique called the Gaussian mixture models, which would work better for this kind of data that has overlaps and has multiple peaks. Again, maybe in future, if there's interest, we can cover that. There are some people in the department who study the mixture models, so I think this would be of interest to them. So the other thing that now you need to do is to scale the data, so the data, the variables have the same variance and the same mean. And for that, they use there's this class from scikit-learn called the standard scaler, which does that automatically for us. So we just feed it onto the transform data, and it will be scaled. I did not do any graphs for the scaled data, but we can leave that out for now. So now the data is ready for analysis. We have gotten rid of the skewness, and then we have standardized the data. So it's processed and ready for analysis. So now when you do the transformations, you lose some information because now the values are no longer in the same units that you started with. But right now we are not so much interested in the units, we are interested in the patterns within the data. So we'll proceed to use this to find the clusters, but then we can connect the clusters to the original data. So the scaling is done. So the important thing now is to figure out what are how many clusters should we consider? So for this, we have code here that will produce the curve, which computes the within cluster sum of squares for each cluster. And we can see, we already saw this in the presentation, the elbow is at around 2, but it might be also worth looking at the 3 clusters. So instead of 2, we shall look at 3 clusters. So later on, maybe you can compute repeat this with 2 clusters and see what comes out. So we shall work with 3 clusters and see what we get. So we take the optimal number of clusters to be 3, as indicated there, and that is what we put inside as a option, the value for the number of clusters in the k-means instance. Now, initially, remember we said that when you start, the first assignment of clusters is a bit random, but depending on where you start, you might end up with some optimal clusters. So there's this option that you have in k-means that is called k-means plus plus. This one uses some smart way to find the clusters so that you get optimal clusters. So we have added that option to ensure that we get with the first guesses for the centroids are good guesses, and then we end up with good clusters. So once we run the k-means, we can extract the clusters using these labels. These labels attribute for the k-means object. And then we put those in a variable called cluster in our original data. Remember, the original data was this RFM data frame. So we have now attached the clusters to the original data, and every client has been assigned a cluster. So now, again, these are 3 variables. So it's having a 3-dimensional view is possible, but not ideal for visualization. So we apply some dimensionality reduction using the principal components analysis. For now, just take this as a gospel truth. There's no time to go through the details of this, but what it does, it reduces dimensions. You're able to view the data on using fewer variables, but still retaining most of the information from your data in a number of cases. So when you run that, this can be a whole presentation on its own, but the important thing is this visualization. So now we can see the 3 clusters and colored. So sometimes the clusters don't come out so neatly like this. Here we are lucky. There's still a bit of overlap between the clusters, but they seem quite well separated. So that's a good thing. But sometimes this won't happen, and you may have to use other techniques to figure out your clusters. Especially if the clusters overlap, then there are other segmentation techniques like the Gaussian mixture models, which work better. So once you have the clusters, you can compute the descriptive statistics for the clusters. In this case, we have computed the mean values for each variable and within each cluster. So we group by cluster, and then within each cluster, we compute the means for each variables. So you can see the values. But now again, from this, it's possible to create a heat map to view this graphically, but the problem is the scales are quite different. So the heat map won't be very useful in this case. So what we do is we just plot these values for each cluster, the value for recency, frequency, and monetary value for each cluster, and put them in separate graphs. That is what happens in the next section. So now this is your analysis of the clusters. Within the first cluster, this is the average value for recency. This is the average value for the second cluster. And that's the average value for the third cluster. So you repeat that for each variable. This one works for frequency, and this one is for monetary. And then you can observe each cluster and see whether it's low on recency, like the first one here is low on recency, or moderate on recency. I think that would be moderate. And this one is low on frequency and also low on monetary value. Then you use that to come up with a strategy. So what follows is a function that looks at the different characterizations of the clusters and tries to assign a strategy to it. This is manually done. So this function just uses conditional statements to determine which strategy. Once you've set up the possible strategies, you can now apply it. So for instance, this was moderate, and then low here and low here. So if you apply it you feed that into the function for the first cluster, which was cluster number 0. We have moderate, low, and low. If you run that as an input for this strategy function, it should pick among the strategy that fits that those options and write it out. So for instance, the one it says for cluster number 0 is further analysis and tailored strategy required. So maybe this needs a little further isolation. The second one had low recency, which is good, high frequency, which is good, and also high monetary value, which is good. So it suggests that you reward and nurture. So these statements are just statements that you'd have to get a marketer to come up with. Maybe you have a team that can come up with, who have experience in marketing and the kind of options you have for different segments of clients. I think at this point is where the mathematician is thrown out and you bring in the marketers. So these strategies are just ideas. They are not based on any special system. They can change depending on the industry and the experience. If you have someone with some domain knowledge, they can tailor this to make them correct. But now once you have this function and you have these values and you can classify them as either low, moderate, or high, you can feed that into this function, and the function will give you the strategy like it has done for these 3 clusters. So that's basically how you do market segmentation using the RFM and the K-means. And this gives you a summary of everything that was done. So anything that comes after this was an adventure. I was trying to do a few more things, but they're not necessary for this presentation. Although there's one more visualization technique that so there's one more visualization technique called it has a big name. I ran it earlier, so not right now. I'll just show you visualization. This one. So this is the t-distributed stochastic neighborhood embedding. It's another reduction technique, but it does a better job of clustering the points that are close together and finds a few more nonlinear relationships that PCA, the principal components analysis, may not be able to find. So you can see when you cluster it using this T-distributed stochastic neighborhood embedding, you can see within each cluster there are some other smaller clusters. So this can make you isolate them and try to analyze them further and see whether you can also have some differentiation within a given cluster. So the only problem with t-SNE depends on the initialization. Every time you run it, it might give you a different view. It is not the same as it's stochastic in nature. So it might give you the same clusters but in a different shape. You have to play around with some parameters and depending on which parameters you use, you might get different looks. But it's also another technique for visualizing high dimensional data. So there's also one other technique which is called hierarchical clustering, which can use to do the clustering. I will not cover this, but this is what you end up with. It's different from k-means because it's a hierarchical clustering system. K-means is a partition clustering system which tries to partition the data. This is agglomerating since you start from individual points and build the clusters upwards. So this can also help you feed into the k-means. You can see there are basically 3 clusters. This one computed 3 clusters. And this tells you that you can also go and look for those 3 clusters in k-means. Now, the thing about the hierarchical clustering is you don't have to know the number of clusters beforehand. It will determine that for you. So you can cut it off at different heights. If you cut it off at this point, you will get 2 clusters. You can also choose to cut it off at, if you cut it off at this point, you will get 3 clusters. So it all depends on where you cut your cutoff is. If you want smaller clusters, you can change the height of your cutoff to get smaller clusters or bigger clusters. But we will not cover this in this presentation. This is just another technique which can also help you determine the number of clusters to look for in the k-means analysis. And once you find the clusters, you can target your customers better. So I will share this script in the chat for those who wish to give it a try. So is a chat. Yeah.
Could you also share the notes as well?
Yes. I believe everyone who registered, the email is stored somewhere. So I think we will forward the slides soon. And the recording is being done by ESDA.
Okay, thank you.
And will be shared as well. Now, I would like to invite questions. Any comments, any suggestions? Since these talks are supposed to be customer-oriented, it may be good to get some feedback on what kind of topics you'd like to learn more about, or what changes we can make to this presentation to... Oh, there's someone who asked, how do we view customer names in each cluster? Now, there are different graphical techniques you can use, but there's if you look at the data itself, already there's a customer ID in the customers may be too many for you to view them in the data, but so there's customer ID. And once you run the cluster, I think I need to find. Yeah, so you have the customer ID. Customer ID is already given. you can use that to identify a specific customer. But now what you're really looking for here is a group of customers, not one customer. So you can identify a specific customer. You can also use, there's a package called Plotly in Python. If you use Plotly, it's possible to actually make it interactive so that when you point with the mouse, it shows you, you can ask it to show you the name of the person attached to this data or the customer ID for this point. So that is possible. You can, there's a package called Plotly, plotly.express if you wish. But you can use that to plot. That makes the graph interactive. And it's also good for dashboards. If you're making dashboards, it can make the plot interactive, and by pointing, you can get more information on that particular point. It's also possible to just plot one point with a different color. If it's a particular set of clients you want to pick up, you can isolate them and plot them using different colors on the graph. But again, if we have a more intense training, then we can go into details of this. Are there any questions?
Yeah, I have a question.
Yes.
How do we do the testing and validation, or how do we ensure that the clusters have retained the reproducibility once we deploy? Are there techniques that you need to perform in K-means?
This is unsupervised learning, so you don't have a test dataset and a training dataset. You only have one dataset. So what happens? There's no prediction you're doing. You're just looking for
Makes
clusters.
sense.
So but that said and done, there's a method you can use to check the stability of the clusters, just to make sure that the clusters you found are meaningful. I did not do that for this, but there are techniques you can use to check the stability of the clusters. So it runs several times and you figure out which clusters are retained and which ones are dissolved. Maybe I should have added that here, but I did not.
Thank you.
Okay. Are there any more questions? So
Yes, there's a question.
Yes.
My name is Vindran. Are you able to share with us the slides too?
Yes, I believe everyone here is registered with email. So I'll organize with Esther so that the slides are shared with everyone who registered.
And one last question. Is this a registered workspace you normally carry out the machine learning projects?
Pardon?
Is this your official workspace where you do carry out your machine learning projects?
What do you mean by official workspace?
Like once we register with you, we can trace through your previous work, or rather what you're doing in future, we become part of it from a collaborative aspect. Because some of us are not students, some of us are also in the field as the data practitioners. Yeah.
Yes, we have a series of 4. I'm not sure I will answer you correctly, but let me try. We have a series of 3 more presentations, and the same link, same time next week and 2 weeks after that, we will have 3 more presentations. But it's the same link that you use to join the presentation, the same Zoom link. I believe it's possible to set reminders. I will ask Mutisia if that's possible, to set reminders so that you can be able to reach me. But my email is available in the presentation if you wish to reach me. Now, I have not posted my work on, maybe I should do this either on some public forum like GitHub where you can access it. But I have shared anytime I do a presentation, I always share the link to the code. So whoever attends is able to download it and play around with it. So the data itself is from, I'll also arrange for the data to be shared. But even if there is this reference here. This is a data source. Or if you just search online for the UCI machine learning repository and search for the online retail dataset, you should be able to find it. But we shall share the dataset along with the rest. We will put everything in one folder and share later.
Yes, please do.
So we will also be running. Are there any more questions? I don't know if you have run out of questions. Or maybe the presentation was not clear. It would be nice to get suggestions on whether. Pardon?
Presentation was very, very, very perfect.
Thank you.
Yeah, thank you as well.
This is quite in order, Prof. But just wondering whether in our local context, do we have supermarket that can actually fill these kind of data sets for, or do our supermarkets normally conduct this kind of customer segmentation?
Some of these are embedded in their customer management systems, the relationship management system. So you can have, I think there are softwares that come with this segmentation embedded, but they may not be perfect, or they may not produce what you want. So if they want to do something different from what they're getting from the software, then they would have to get someone to do separate analysis. Whether they're willing to share the data, you would have to reach out to them. I have not done any analysis with a local outlet. You'd have to reach out to them and see if they're interested. Maybe you would have to talk to them and show them what you can do with it, then they will reach out. If there's anyone who has done that with a supermarket here, maybe they can share the experience. Yes?
I'm involved in a future project the next coming weeks where I'll be working on a machine learning project based on the credit collections, and they'll be part of segmentation. So I'll collaborate with some individual who has got the same interest. Yeah, it will be a local data set.
So you can see there's a demand for it already locally.
Maybe you can share his details to us so that we can get in touch.
I believe I'll tap my mail on the chat area.
So you can also explain what you mean by collaborating with the others.
Like for instance, if you want to do the local project,
yes,
I'm going to do a pro bono. You see, we have got these scenarios where the credit collection sector tends to have one particular way of asserting pressure on the customer without knowing their needs and how to handle them. So as a way to figure out a niche in that they can use machine learning, leverage it to find a suitable measures on how to deal with different clientele. For example, a high value customer won't be treated the same when he's going to default as someone who came in walk-in with an ill motive, for example. So if the machine learning is able to give us the segmentation as they want it, like for example, the KNN, give us the clusters and they're able to see and then apply the right strategies, then the niche will come up. People will participate in that project in the pro bono, that is, we'll have leverage once the idea is bought in. So we can now talk in a commercial perspective. This is what it takes. This is what we need. So that is what I mean by collaboration.
PNN is for classification, not for clustering. but it's appropriate for that data because you probably will have labeled data.
Yes, I'll have labeled data automatically.
So I don't know if Mutisia is around. He can talk about we shall be running a short course for 3 days in March, from 19th to 21st of March. That one will be physical. Maybe Mutisia can do a presentation on that then if he's still around. And I think that will be the end. We have done the full hour. So the short course will be paid. There'll be some payment involved, but there's a Google form you can fill up if you're interested, so that you can get all the details. But these seminars will continue. These ones will be free. You're free to attend and also gain as much knowledge as possible. And we now in the training. It will be a little more intense and we'll be able to move a little slower and explain all the details so that someone can walk out with their with some good understanding of what they need to do. It will also be possible for people to come with their own data during the training. Their data will not be used for the training, but they can apply some of the things to their data during the training. If you have some data that you wish to analyze, then some of the concepts we run through the training, you should be able to apply to your data. So I don't know if Mutisia is around.
Yes, I'm around. Okay.
Can I hand it over back to you? And
yes. So thank you for that presentation, Dr. Katende, and I trust everybody got a feel of what the course is about and everything that you're going to do. As Dr. Katende has said, we are going to be having a very intensive 3-day course running from March 19th to the 21st, and this is going to be a full-day course. I will share the link for the registration and also the poster of the course, which shows the costing and everything when I also share this recording and the data that you have used today with you. Otherwise, if there's no any other questions, thank you very much, and I wish you all a blessed day ahead. Thank you.
And Prof, we followed you on LinkedIn. Kindly respond to our connection.
Okay, I will do that.
Thank you.
Thank you.
Bye.
I have a question.
Yes.
John.
Yeah. So I was wondering, for us who are beginning in this machine learning, since we can't handle large data sets at the moment, how can we use smaller data set when we are given a very large data set?
You don't have to work with a large data set when starting. You can, even from the same large data set, you can cut off a small bit just for practice purposes. There are ways to sample data so that you have a smaller data set to work with. There are also small data sets available publicly in the public repositories, like the UCI repository that I have mentioned. You can find both large and small data sets for practice.
Thank you.
So the Kaggle also has a lot of different data sets, both large and small. So there's something for everyone in those repositories. And some of those repositories also have some scripts.
All right.
Yes.
Thank you.